Ladies and gentlemen, this is Mark Anderson for Kellogg Community College, and today we're going to be talking about some basic logarithms here and some special ones. Now, we've learned about logs that can be in all sorts of different kinds of bases, but this is a base of e. E is a number. It has some pretty cool properties to it. This is the stage or the exponent, and then this is going to be the result. And as I have taught logarithms in these videos, we start off with the base as our corner of the log. The result is what's in the parentheses next to it. So this is 0.1353, and this gives us the stage of -2. Well, what's interesting is that this log base e is actually known as natural log, or ln. You can use a cursive letter L if you'd like to, but if we type the natural log of 1,353 ten-thousandths into our calculator, it would give us an approximation of -2. So in short, natural log is ln, or whenever you have base e. Now, on this side, where we have our base as 10, so this would be log base 10, this would be the stage right there, and this is the result. The result is going to be my 2 right there, and this is going to be equal to 0.301 or 301 thousandths. This is an example of common log, because common log is in base 10, so this can be rewritten as just log. We don't actually put the 10 here, and you can see that in every graphing calculator you can click the log key, which would give you base 10. So if you click log, parenthesis to parenthesis, this will give you an approximation of 301 thousandths. So in short, common log is written as log, or base 10. Now, to go down here, you should get out your graphing calculator, and you should type these in just as you see them. And I've got my graphing calculator, which I'll bring up here. And I can show you that just by typing these in, you can get your answer to these problems. So here's log 7 is going to be this approximation, and we're going to go to 4 decimal points, so that's going to be rounded to the nearest 10,000th. The next one is going to be log 0.25, which is going to be -602 thousandths, or 6,021 ten-thousandths, if I rounded that correctly. The natural log of 13 is going to be 2 and 5,649 ten-thousandths. And we're going to write these down before I get to the final one here. So let me get these down. You can write these in if you'd like. 8,451 ten-thousandths. -6,021 ten-thousandths, 2 and 5,649 ten-thousandths, and for the last one, we're going to have e, and you'll notice when we do e, we go second log, and it automatically puts that up in the exponent for me, and so this gives us 15 and 293 ten-thousandths. Now, for our final 4 problems of this video, we're going to take a look at evaluating and solving. Now, what's kind of nice about these is if we do our translations correctly, we should be able to get our answers pretty straightforward for these problems. Because this is asking, okay, so it's in a log. If we translate this to an exponential, this would be a pretty easy thing to solve or answer for us. So the base is 10, the power is x, and we want to get to 1,000. So the answer here is going to be the power of 3, because 10 to the 3rd power is 1,000. Now, later on, we're going to be learning the change base formula, which would make this even faster. Here, we have the base of x, the power of 4, and the answer is 16. So it takes just a little bit of reverse engineering to think about what number raised to the 4th power would be 16, and that number would be 2. Another way you could do it is take the fourth root of both sides, and the fourth root of 16 is 2. Here we have the base of 2, the exponent of 0, equaling x. So what is 2 to the 0 power? Well, that answer for x is 1, because anything to the 0 power is 1. Finally, if we have the base of 4, and we have the power of 2, the answer is x. So in this case, the answer 4 to the second power, x is equal to 16. Alright, thank you for watching.